Now we're writing linear equations when given a graph. Here we can use slope-intercept form or point-slope form depending on the graph. When and where we're going to utilize those different ones, well, here's some things that we're going to look for. All right, so here's some things to look for. Positive or negative slope, identify two exact points, draw a slope triangle, do we have a y-intercept? Okay, now when do we use what? Well, if the y-intercept is known and it's a whole number, we're going to use slope-intercept form. All other times, we're going to use point-slope form. So let's take a look at a couple examples and see what we mean here. So, first of all, exact points are points that actually intersect on the grid lines of the graph. Okay? So if it intersects on a grid line of a graph, then it's an exact point. If it's floating somewhere out in the middle, it's not an exact point. We don't want to use it. That would not be good. Okay? The y-intercept as a known integer value means that it's touching the y-axis at a whole number, so at one of those hash marks. Okay? We're not guessing. We're not saying, oh, well, it looks like a half. Okay? It has to be a whole number if it's going to count for the y-intercept. Let's take a look at some examples. So first, here's an equation. Plot two exact points. I realize this grid here is not showing up the best, so I'll try to help you as best I can with what is exact and what is not. As I'm looking at this, we have an exact point here. Okay, that exact point is actually 2, 0. And then we have an exact point here. Okay, and it looks like that one's going to be -1, -2, -3, -4. All right, so we know the y-intercept. So we're going to use slope-intercept form. We can find the growth by drawing a triangle. So if I draw my triangle in, that triangle is going to go up 4 over 2. So don't forget, that means rise over run. That reduces to just 2. Now I can write my equation once I've identified those two pieces. So y is going to equal 2x minus 4. Let's take a look at another example. What happens if you don't know all those things? So in this example, you'll see here the y-intercept. We can see it. It's visible, but it is not an exact point. All right, it is somewhere between. It's somewhere between 1, 2, 3, and 4. So we're not going to use that to write this equation. Not a good idea. So we're going to use points that we know. So right here, hard to see from your perspective, but that is intersecting at an exact point right there. And that point is -1, 4. All right. Now search my graph for another exact point. Just so happens the x-intercept is an exact point. There might be others along the way here, but this is the one that I see first that I'm going to choose, and that is 5, 0. So because I don't know the y-intercept, I'm not going to use slope-intercept form. I'm going to use point-slope form, but I need to know the slope. So if I draw my slope triangle in, I'm going to go down 4, and I'm going to go over 6. And I can just count those blocks for that. So a down 4 is a -4, over 6 is a 6. So my slope ends up being -4 over 6, which is -2/3. And then I'm going to choose a point, such as this one, to write my point-slope form. Now, if I choose a different point, my equation would look different, but Mr. Warner will still give me credit. Y minus 4 is going to equal -2/3 times x minus -1, which is +1. That will be the point-slope form of my line. Let's take a look at another example. Okay, so what happens here? We got these giant numbers. We don't want to count blocks. This is something that we struggled with on the last test. Okay, so what do we need to do here to be able to write the equation of this line? This is something we're going to have to be able to do, all right, because we're going to have to be able to do scatter plots and so forth. All right, so first let's identify two exact points on this line. All right, it looks like we're going to have an exact point here. Okay. And if I go down my graph a little farther, I'm thinking that this is an exact point here as well. Now, anything I'm giving you in class is going to be a little more visible than this. I know it's hard for you to see from home there. But those are my two exact points. Let's identify what they are. So if this is 100, and there's 5 blocks here. It's counting by 20s. So that's 20, 40, 60, 80, 100. So this looks 80 and 220 is that point, 80, comma, 220. And then this point over here would be 200, comma, 120, since both axes are counting by 20s. I'm going to draw my slope triangle. Now here's where some of us got stuck on the last test, because we just counted blocks instead of counting by the actual units themselves. So if it's going by 20, it's going to go 20, 40, 60, 80, 100. So it goes down 100, and it goes over 20, 40, 60, 80, 100, 120. Okay? And it goes over 120. So that's how I get my slope. M is going to equal negative 100 over 120. I want to reduce that fraction. So that's going to be negative 5 over 6. I'm going to use point slope form because I don't know the y-intercept. I can't even see it. I can't even see it up here on the graph. I know it touches somewhere, but I just can't see that. So let's choose this point. Here's my slope. Y minus 220 equals negative 5, 6, x minus 80. And that's it.